Futures. My name's Ava and I've been part of the organising committee for this event today. Today's event is called Green Giants Industry in 2050, and we can promise you that this is going to be a very exciting debate. Just a bit of housekeeping. If you are a University of Sheffield student or you live within the area, then please scan this Better Points QR code now. If you go to the 3-line tab, I think it's in the top left. It's in the top left of the app interface page. You can claim 500 Better Points for your attendance, and this equates to a free coffee with your own mug. So please do utilise this opportunity. As a little thank you from our sponsors for attending today. I'll just give you a few more seconds to do that. Right. So we've been overwhelmed with, positively overwhelmed with the engagement with sign-ups for today's event. We've had a very big uptake, but I think this is only a fair reflection on the notable panel that we've got with us today. So each member will be introducing themselves, but just a quick overview of who we've got here today. We've got a mixture of academics and industry professionals who will hopefully offer their own unique stance on the topic. So our chair today is Professor Rachel Rothman from the University of Sheffield, based in CBE. Also based in CBE, we've got Professor Solomon Brown, who's an academic of process and energy systems. And then we'll also be joined by Dr. Fanran Meng, also an academic in the Department of Chemical and Biological Engineering at the University of Sheffield. So over to the industry side of things, we're joined by Steve Winkley from ABB and Joan, who bridges that gap between academia and industry. So let's get going quickly because, like I said, we've got so much to get through today. So I'm very honoured to pass over to our chair, Professor Rachel Rothman, who is also the co-director of the Grantham Centre here at the University of Sheffield, and her research is in sustainable processes and clean energy systems. And as I said earlier, she is a professor based in the Department of Chemical and Biological Engineering here at the University of Sheffield. So thank you, Rachel. If I could please pass over to you. Thank you very much.
Brilliant. Thank you, Ava. Welcome, everyone. I'm really excited for this panel session and debate today because we've got lots of interesting things to think about. We've got some really excellent speakers lined up who come from different backgrounds, and hopefully we can really dive deep into what industry might be able to do going forward if we're going to meet our net zero goals. So what we're going to do is each of our speakers will have 5 to 10 minutes to give a presentation about themselves, what they do, initial thoughts. Following those speakers, we'll move into the question and answer and the debate section. So we've got a few pre-submitted questions that we'll be going through, but also lots of opportunity for you in the audience to ask questions. And the way you do that is by using the chat function. So in the bottom right of your screen, there's a little speech bubble icon. If you click on that, you will be able to ask questions using the chat function, and I will do my best to get through them all. And because there's so many people on the call, it won't let participants speak yourselves, I'm afraid. So use the chat function and I'll pull the questions out to ask to our panel. And if your question is to a specific person, can I suggest that you put that in square brackets or something at the start so we know who it's for, whereas if it's to everyone, just leave it open as a question for everyone. I think that is all of our housekeeping and instructions, which means we can move on to our first speaker. And first up, we have Steve Winkley. Now, Steve is the UK Metals Sector Sales Manager for ABB. ABB is a technology leader in electrification and automation, enabling a more sustainable and resource-efficient future. And he leads on, or they lead on the electrification of steel production away from coal and coke-fired blast furnaces to electric arc furnaces. Over to you, Steve.
Right. Well, thank you very much for the introduction. And I guess really what I need to do is just introduce myself and, where I'll sit on this panel. I'm not an academic. You'll see lots and lots of academics. Well, I'm not an academic. I'm an engineer. So my training was electromechanical engineering. I did systems engineering then in my degree. And I quickly moved in the late 1980s, early 1990s. I moved into work for a big electrical company, GEC. And GEC spent its time really electrifying heavy industry. So a lot of the heavy industry you've got in the UK, a lot of the steel industry, shipyards, has a lot of the stuff that GEC did, or I did, especially in the steel industry. I worked there for 17 years. So I put in a lot of stuff. And what you saw during that time was automation being one of the key things that happened in industry to make industry more efficient. I then moved to manufacturing industry itself. I worked for Chorus and Tata Steel. Tata Steel being one of the major single point emitters of CO2 in the UK. But I also worked for what is British Steel now, which is another one of the major CO2 emitters in the UK. So I worked then as the lead process development engineer for rolling mills, and then later as a CapEx project manager. So I was responsible for doing big projects, putting new process lines in, putting electrification at an industrial size that is probably hard to grasp for normal people. But from an engineering point of view, when you add a motor to a rolling mill, it's not just a motor, it's something that weighs over 200 tons. It's something that's sort of 12.5 megawatts base power with a 2.5 times overload. And you need a couple of them probably for your rolling operation. And the torque that it produces is the same as, if anybody's into cars, 10,000 BMW M5s. It's a big bit of kit and it uses lots of power. So I also did things like blast furnace rebuilds. So I'm on the panel representing industry. Industry has tried to make itself better, but it's a business. There are lots of things that stop industry just magically making a better, more sustainable world. One of the main things is that industry is about making money for people as well. So I'll have an interesting view compared with the rest of the panel as far as that goes. I was born near a steel town in the middle of Northamptonshire, Corby. So I grew up with a steel town, and I grew up with what happens when a massive industry employing 25, 30,000 people suddenly doesn't exist anymore. So I then lived in a community where a huge industry disappeared. Anyway, I thought that was a bad idea. So I moved to South Wales to near Port Talbot. So now I live near Port Talbot, and Port Talbot is, as I said, one of the largest single emitters of CO2. It's facing a very real future at the moment, where as a business, it's not in a position where it's sustainable to go forward. And that means huge community, which is supported by that, lots of very well paid, very good jobs in the area, are under a huge amount of risk. So that industry is a sort of industry where it's very, very capital intensive. Things don't just change, because somebody makes a little bit of a difference. People make a massive investment. The industry runs for about 25, 30 years. The equipment wears out, and then you make a massive another investment. And you can see in the case of these big steel companies that happening. So in 1960, the steel industry in South Wales became an integrated works, and created another similar works in Llanwern. And for a CO2 point of view, that means huge industry and a works that has blast furnaces, which produce lots of CO2, but the whole of the process is joined together to use all the byproduct gases. So as a system, it works very well. So that happened in 1960. In 1990-ish, a lot of the rolling mills became automated. Improved efficiency means you have less remakes, less waste. So that has an impact in the carbon cost of the products you make. Now in 2024, all of the equipment really to make iron and then to make steel has come to the end of its life. And that happens in Port Talbot, it happens in Scunthorpe. So all of these companies are facing a huge dilemma now, is that, do they stay open? Do we still need steel in the UK? And if we need steel in the UK, how on earth do you spend the money that you need to change that industry into something for the future? So we're sitting at a point at the moment where we're looking for the next 20 years, 25 years. So it's a real big decision time. And these companies that you will see now, and I think the academics will probably talk about it, they're faced with decisions whether to try and store the carbon that they make from their processes, or try and use some new technology, which is by no means certain at the moment. So try and replace, how they make iron and how they make steel. So you're looking at things like, the use of direct reduced iron, using hydrogen to reduce it. It's not a technology that's really there you can grasp hold of at the moment. You're also then looking at, well, what can you do? Because the equipment that they've got has actually fallen to bits in a lot of cases. The steel process at the moment involves, you make iron to start off with, you need coke ovens. All of the coke ovens in the UK now are closed. So at Scunthorpe, they closed, at Port Talbot, they closed, which means you can't make coke anymore. So the start of the process is broken. You can't recycle the gases that are made in the process within the plant. So it's already started to stop. The next thing is the blast furnaces are coming to the end of their operational range. So you need to do something. So there's a few things to think about and to debate. One of the things I'm sure we'll get into is, well, what do you do with that steel industry? What do you do with the jobs that suddenly disappear when you close half of the plant? Do we need steel? Yeah, we're all sitting here. We're looking at this on our phones, on our laptops, full of steel chassis. We're sitting in a building which is held up by rebar, full of steel. We've probably travelled today on some form of transport. We've, big thumbs up. We've thought ourselves green, so we've pedalled in on a steel push bike. It's everything that we do. We'll have a meal a bit later, and it'll involve steel. There'll be a knife and fork, which will be steel. So there is no part of modern life which doesn't involve steel. So we have to have a think. What do we want to do with all this steel? So another point for debate a little bit later on is, do we need to make new iron to make steel in the UK? At the moment, we export scrap. We export 8.5 million tons worth of scrap overseas, which we could use if we thought it was a good idea to melt down and actually use here in the UK. So is it right that we move raw materials around the world at great CO2 cost when what we really ought to be doing is recycling? So there's a lot of things that we ought to discuss a little bit later, but that's sort of basically it, really. Do we need steel? I think, of course, we need steel. Do we need the sort of steel industry we've got at the moment, or is the way it's going? Should we recycle where we possibly can? And then if we do that, what do we do for 2050? Where do we go from there? Because we'll need to make new iron and new steel. So what's the next stage? And it all comes down to the power industry and power generation then. So I'm sure we're going to have some interesting debate around that. Anyway, that's me. I'm probably the bad boy. I'm the industry representative. So with that, I'll hand you over.
Brilliant. Thanks, Steve. Lots of really interesting things that we can pick up in questions. For those that have joined us more recently, we've got 4 speakers who are talking first, and then we'll move into the Q&A. If you've got questions, you can put them in the chat, and I will be reading the questions from the chat as well as the pre-prepared ones we've got. So our second speaker is Professor Sol Brown. Sol is a professor of process and energy systems, and his research focuses on mathematical modeling, process analysis and optimization, with a particular focus on clean energy processes, energy storage and energy systems. Over to you, Sol.
Don't forget to unmute. That's the normal thing. I'll share some slides just because pictures help my very slow brain. So I'm Professor Sol Brown. As Rachel has introduced, I do energy systems research. I lead a group into clean energy processes and technologies. We look at sustainability, covering quite a lot of the technologies that Steve has just talked about. And we analyze those technologies and try to look at them in the context of the wider energy system in which they behave. I have been at Sheffield for 8 years now, which seems a very long time. I lead a group of researchers looking at kind of a range of these different things, from kind of carbon capture and utilization, with some application to steel manufacturing, across to energy storage, safety of energy storage technologies, and then economics and process analysis of different various things. We also develop machine learning technologies, but they're different things. I included a picture here just to prove that there were people in the group, because sometimes I find that you need to reinforce that in some talks. But there, we found a nice staircase to stand on and smiling. So that's the group. I guess I wanted to flesh out a little bit of what Steve was going to say, with kind of outlining the strategies that you use. And these are very generic and will be different for a particular plant that you use for decarbonisation of heavy industry. So generally you have 4 things that you can do, right? So you can look for greater energy efficiency in your processes. So when Steve was talking about kind of digital tools and automation, you're looking for energy efficiency savings there, and that provides potentially very large savings in the context of your some. You can fuel switch. So you could either move to biomass, which some people think of as a green fuel, or hydrogen, which you produce off-site and through combustion produces no CO2. So you can fuel switch something that might be gas or coke into something which is nominally carbon neutral. You can electrify your process. So when you're talking about steel, that's kind of the use of electric arc furnaces. So you create kind of plasmas which are extremely hot, and then they melt your steel down. Or you can apply carbon capture. So again, carbon capture is a technology that could apply to a blast furnace. There's a CO2 blast. The gas that comes off a blast furnace contains CO2, and you want to strip that out. You reuse some of the other gases that are in there and do something with the CO2 that it's useful. I guess having efficiency is one thing, but it's worth noting that kind of fuel switching and electrification are not necessarily one-to-one switches with the technologies that you're looking to replace. So electrification means that of steel, for example, means that you're probably unable to produce primary steel, and we then have to look at recycling steel, and then you have to think about the shift towards recycled steel more globally, and whether you end up in a very competitive market for people's thrown away steel goods, which we're arriving at quite quickly, or hydrogen within blast furnaces and the different heat transfer requirements properties of hydrogen that you get when you try to use it within furnaces and kilns, if you're looking at things like cement. So the different properties of these technologies can mean that you cannot produce exactly the same product. That may not be a thing to worry about, or it might be. And efficiency in carbon capture essentially attempts to maintain the technology as it is, but to deal with mitigate the CO2 emissions on the back end. What does all of that mean? Well, if you electrify stuff, it means that inevitably, once you have lots of different plants who are trying to electrify their processes, you have a much larger amount of energy generation required. So the demand goes up. You have an electrical network which then needs to be able to move those electrons around our system, and that for the UK means that we would likely need to have more wires, kind of big wires, to allow us to move more electricity around. It would also mean that we need to deploy more generation in particular places in order to support our networks so that they don't collapse. If we want to deploy carbon capture, then we need an infrastructure for that. That doesn't exist at the moment. It's been planned for at least the last 25 years, but has never actually happened. And what you need there is the ability to move captured CO2 either to where it's going to be used, kind of utilized, or offshore to where it would be sequestered, stored under the sea in a geological formation. And the main problem there is money hasn't come forward to do it. So this technology is readily deployable at a reasonable technology readiness level, but it's just expensive, and that money hasn't come forward. And if we talk about replacing fuels, then we're talking about introducing, again, new infrastructures. So we need to have an infrastructure for both generating hydrogen and for moving it to the places where we have demand. If we're thinking of centralized infrastructure, and then with increased UK policy on integration of heat and heat networks, industry will have to sell heat that it produces into heat networks in order to decarbonize residential heat use. So we're thinking, looking forward, layers of infrastructure that need to be planned, financed, and deployed, and all of these things that mean basically that the industrial decarbonisation is not a thing in itself at a plant level. It's a whole ecology of different decarbonisation strategies and infrastructures that need to come together in order for it to be delivered. Right, so that means you have, and each of the actors within that ecology has autonomy, so they can decide what they want. And that is one of the primary issues in developing these infrastructures, because you need to bring forward the demand for each of those technologies to get the infrastructure in place. So what does that look like for the UK? Well, the UK sort of understands that this is the case. That's why we have a whole load of clusters that we've defined. So UK has a range of different industrial clusters for the UK. All of them are on the coast because they are essentially dependent on carbon capture and storage. So the big steelworks in Scunthorpe and in South Wales, you can see are kind of the heart of clusters, because they will require some carbon capture and or they will need lots of hydrogen, and both of those things will have to happen in one place, and so you need access to offshore, essentially. So we have plans, albeit they haven't moved very far forward in 25 years, for decarbonisation clusters in the UK. I guess the remaining question is, what do you do with the bit that's not on the coast, which is actually quite a lot of the emissions? And the truth is that the UK has no policy for that. They've put virtually no thinking into it, because most of the emissions that they can target at single points are on the coast. And for Sheffield, that's sort of bad, because we're in the middle. And if you look at us, then we do have centres of demand for fuel switching and for some of these technologies to be delivered. But there is as yet no plan for utilising the ecosystem, the ecology, the infrastructure which is deployed on the coast to extend that into the interior of the UK. And so we're somewhat limited, if you're not on the coast, to the number of strategies around electrification and hydrogen, which can only be delivered at limited volume. So I think I've said enough there. I think what I wanted to emphasize was this sense that it's not an individual decision, it's an ecology, and providing industrial decarbonisation is really providing that ecology and feeding it with the technologies that it needs. And with that, I'll be quiet. Thank you very much.
Thank you, Sol. More interesting points. I understand that some people are having difficulty with the chat function. You can also use the Q&A if that works. To get to the Q&A, if you click on the activities, which on my screen at least is a triangle, a square and a circle in the bottom right. If you click on that, you'll see the ask a question button, which takes you to the Q&A. And I can see a few people have posted in the Q&A. So hopefully that means people will be able to post there. Let's see how we go. Whilst we're trying to solve that, we'll introduce our third speaker, who is Joan Cordiner. Joan is a professor of chemical engineering and is head of the Department of Chemical and Biological Engineering at Sheffield. But prior to that, she had a distinguished career at Syngenta and other chemical industry, and they're a leading science-based agritech company and span several global and senior management positions. So over to you, Joan. Joan, we can't hear you at the minute if you're speaking.
Rachel, can you see the screen?
Ah, yes, I can see the screen and I can now hear you as well.
Yeah, excellent. Well, that mute button got me. I'll give you a little bit of background. I graduated a hell of a long time ago, and I worked really right across industry, starting off in what would be sort of plastics and polymers and polyethylene catalysts. Moved to the US and worked on acrylics, came back to the UK and worked on alternative refrigerants, the Clear 134A and Clear 32. Then moved to agrochemicals, all as a process engineer, and then became a technical operations manager, where we did all the pilot plants and small scale manufacturing. Then took on a kind of global consultant role where we did research within the company and with universities all around the world. And then worked out when there were problems in plants, I would go and help them out. Then I moved to the US as formulation manager, that's making products instead of just the chemicals, and introduced all the new products in the US. Then I went into turning around failing plants. Our first speaker talked about old plants and what do you do, how do you manage them, and if you haven't looked after their maintenance well enough. So I have lots of experience in working in very old plants and trying to keep them safe and keeping them economic. And in most of those plants, they used an awful lot of energy. I'll give you an example. For the plant I managed in Houston, our bill for energy was 68 million a year. That was half the cost of the whole site costs. So any transition in energy is a huge issue for chemical plants, for pharmaceutical plants, for plastics plants. It's a huge problem, and if all we do is make it much more expensive, then we have the potential to do what the first speaker talked about, pushing more and more manufacturing outside of this country and losing jobs. I, like the first speaker, grew up in an area that had mining, and the mining jobs went. I also had BP just over the hill in Grangemouth, and at 8 years old, the windows in my bedroom were shattered at some like midnight, certainly when I was sleeping, because the catalytic cracker had exploded. These big industries that we rely on every day, and just like you use steel every day, all of you eat every day. And in Syngenta, one of the statistics we would talk about is 28,000 people a day can eat per employee because of the extra food production our products would enable. So in doing all this good, you also have these huge plants and factories that take a lot of energy, and they have changed over the years. If I think about the transition we have to make over the next 30 years in decarbonising, it in some ways is similar to the environmental transition we've done over the last 30 years. It's not the same. It doesn't have as many problems as the transition we're about to make has. But over my career, I've seen the amount of toxic substances released from chemical plants and oil and gas refineries hugely change, because we've brought in new technologies to reduce waste, to reduce what we put out to the atmosphere, and to improve the processes so they're much more efficient. And although 30 years ago, people thought that all this new environmental stuff and all the new process safety stuff that was brought in was going to put the industries out of business, actually what happened was there was lots of really, really innovative work that was done that made things a lot more effective. Now, of course, we did lose some businesses to overseas as well. So in this coming transition, we need to find a way of doing it equitably so that the vulnerable people don't have to pay huge amounts for electricity, that plants and manufacturers can afford to stay in this country, and that there's a benefit to staying in this country and having the jobs here, because we can come up with really innovative processes. They say that necessity is the mother of invention, and certainly during war we see that. And as legislation's put in and companies are made to do things, it's amazing what engineers and scientists can come up with. And so I'm a real big proponent of regulation and policy to help drive the way we need to be. I want to show you one more thing that we need to think about in our transition. I was based in Houston before I retired from Syngenta, and one thing you will know about Houston is it's been in the news for lots of hurricanes. This was a plant, I was a manager there, and we had 1 meter of rain in a 4-day period. It was the wettest hurricane on record in the US. 70 people died. We had huge winds. We had tornadoes hitting the emergency shelter on site. It was a huge issue. And these are the sort of scenes you would have seen on the news. By the way, the picture on the top right was my route to work. Just beside our plant. The picture on the bottom left was a picture from just across the plant. So not only do we need to think about how we fund, how we design for the energy transition, but we're also competing with climate change. And we need to think about that in our processes and how we design our processes, but also how we protect things and keep them safe. And that's a big part of my career has also been about managing process safety. And if you think about the transition that we have to go through over the next 30 years, process safety regulation has been written largely as a result of accidents that have happened in the past. And with all this new technology coming forward, we need to make sure that we don't make the same mistakes. So thank you.
Brilliant. Thank you very much, Joan. Even more things to think about. We've got one final speaker, but we have a couple of ways that you can ask questions. So if you've got burning questions already, there is the Q&A, which is on the Google Meet. If you click on the triangle, square and circle in the bottom right, you will find the Q&A there. And for those that are struggling with the Q&A, if you look in the chat, there's a link to a Miro board and you can leave questions on the Miro board. I think they're just trying to make it a difficult job for me having to chair this, having questions in all sorts of places, but we will do it. So our final speaker is Dr. Fanran Meng. He's an assistant professor in sustainable chemical engineering whose research focuses on resource efficiency and engineering sustainability, driving reductions in environmental impact and the development of sustainable engineering practices. Over to you, Fanran.
Thanks, Rachel, and I hope you will hear me well.
Yep, we can hear you. Thank you.
Great. Hello, everyone. My name is Fanran Meng. I'm really glad to speak at this nice event and talk about the green stuff and industries in the future. So, my talk is slightly different from what Joe talked about, more about these career share. Because I'll probably more about from the research experience I've done and how we can model these development models and driving the sustainable transition. So my research focus, well, a little bit about myself. My background is in material engineering. So I did my PhD in University of Nottingham and working on the carbon fiber material recycling. And then after that, I did a few years postdoc in Nottingham and then University of Cambridge, understand resource efficiency on the macro level, understand the industry, particularly on chemical industry. And then I joined Sheffield last year in the CBE department. So research perspective, I put these keywords as resource efficiency and sustainable engineering. So on the diagram on the left is I put a few the technology in the kind of quite bottom level, how we understand the technologies and the materials design and link these microstructure design and selection of the different elements, for example, our batteries, and then link to the performance, and then to scale up all the way to this macro level, how we can understand its environmental impacts and also the supply chain perspective, using some whole system approaches such as life cycle analysis. And then last is we assess the current status and understand the technology developments. How can we optimize them using some existing data and also prospective modeling, so they can best inform some decision making and investment. And then these some main areas for my research ongoing project really focus on these renewable energy systems like wind turbine technologies and materials in the life for circular economy. And then on the industry level, how can we decarbonize the chemical industry and using some advanced modeling tools. So next slide, please. So in the next few slides, I'll give you some kind of examples of the research. How can we use the life cycle thinking or this whole system modeling to inform the industry and to drive the transition? So this is the Sankey diagram on global petrochemical system. It's done in 2017, and that only measured this global mass flow. So everything from on this diagram is measured in mass, and then in 2013. So from left to right in this Sankey diagram, that's what we call it, is tracking the raw material from the left. It's like oil and gas and other source of energies, and then to its primary chemicals material like ethylene, propylene, and ammonia, all the way to some intermediate chemicals, and then to the products like thermoplastic, thermoset materials, and also nitrogen fertilizers as the main chemical products on the very right. As you can see, it's quite complex and a lot of processes are intertwined. And if you evaluate one process, you have to think about how that can affect others. And that's why, and also not only what I have shown on this Sankey diagram, but can each of these this flow, there might be a few hundreds or thousands of processes happening, and as well as those thousands of different products. So it's quite complex and difficult to decarbonize. And so my research tried to clarify these emissions and based on the different chemical production. So if the next slide, so which is about, so on this overall level to quantify the emissions. And so we got global chemicals production, and then try to clarify the emissions across different dimensions. So these have 5 sub-figures. You can see there's try to organize these emissions from different dimensions. One is region, so the country level, the China, US, and different other regions, and then to the product group, because from the previous slide we have understand a lot of different type of plastic, different type of chemical products. On this diagram shows the different products group, the thermoplastic, and then how much the emissions really occurred in these products. And then it's the different emission sources. And if you have understand what's the life cycle of the processes, where emission occurred or come from, indirect energy use or direct processes, feedstock materials, and energy use, and also linked to, you might also be familiar with scope 1 to 3 emissions. I think to the D is more different type of greenhouse gases, might be CO2, methane, and then N2O and other type of greenhouse gases. And then lastly, the different time series, historical data, historic emissions, and also prediction of the future. And so we did this work and quantify these production of chemicals. So the total cradle to gate emissions was 2 gigaton CO2 equivalent per year in 2023. And also it is expected to rise to over 3 gigaton CO2 emission equivalent in 2050. And we also compare with some existing estimation done by International Energy Agency. So it's a really good fit with what we have done. And so quite example is we can use that kind of analysis tool to understand, for example, thermoplastic, the really largest share, as in the figure B shows, about 75% of the emission occurred due to thermoplastic material production. Okay, the next slide. And then if you look at a particular chemical along the supply chain, and if this one's diagram shows the different emission intensity for ethylene production, and on the y-axis it shows emission intensity factor, which is measured in kilogram CO2 equivalent per kilogram ethylene. On the x-axis, different feedstock or different types of process technologies to manufacture ethylene products. As you can see on this diagram, there's about more than 63 different processes of making ethylene, and also this is based on current known processes. And then the processes, you can see the greenhouse gas emission and value really vary across different type of feedstock and different type of technologies, varying below 1 kilogram CO2 equivalent per kilogram ethylene to over 8 kilograms CO2 equivalent. And then the different processes using coal and have higher emission factors compared with processes using naphtha. So we're trying to, for the future technology development, or for the chemical industry to consider is how can we drive away from coal and methanol towards some other low emission intensive processes or technologies using like ethane or naphtha. And also, of course, there are a lot of uncertainties. How can we understand these processes and or improve the accuracy in the future? So the next slide talk about uncertainty. How can we improve or reduce uncertainty or improve accuracy? So some example we have done, if the kind of a given example, if we know product only, what product we manufacture, and then do some estimation based on existing knowledge or data, this is about more than 50% uncertainty. If we have a facility data, understand the production things, or even know the feedstock data or specific processes using to produce the one particular chemicals, then we can reduce these uncertainty to really low level. So the figure B tells us generally across so many different chemical and processes. So if we increase 20% of the data collection for the facilities of chemical plants, then we could potentially reduce over 80% of uncertainty. So this is a huge difference, and that's kind of call for these action from industries or other policymakers to drive this data transparency and uncertainty, to reduce the uncertainty overall. So that's kind of a targeting thing. And the CNG tells us different kind of impacts if you increase the data transparency and can help us to reduce overall emissions. So this is kind of example. I hope you give you some ideas, and there's a paper you can scan to read and about how we can use the existing chemical engineering knowledge you have learned of, and also use some advanced sustainability modeling tool to help us and drive reduction for the chemical industry to achieve these net zero targets by 2050. So I think that's pretty much from me. And if you have any questions, feel free to type in the chat and also email me. As the slides and the first thing, and I'm happy to share the slide if you need to. Thank you very much.
Fantastic. Thank you very much, Fanran. So I can see that the question and answer function is working well. We've got a few questions coming in there. So just as a reminder, if you've got a question you would like us to ask, you can type it into the Q&A function by clicking on the activities button in the bottom right, which is the triangle, square and circle. Click on there. You can then select to get into the Q&A and you can type your questions there. And if anyone is still having trouble with that, then there's also a Miro board, which I can see a couple of questions on. So you can type questions there as well. So I am going to take one of the ones out of the chat first. And it says it's to Steve, but I think we might ask it to a few people. But Steve, you can maybe go first answering this. So do you believe it's solely the government's responsibility to incentivise emissions reduction? Or do you think there are proactive measures that industry can also take to contribute to that goal? And if so, how do you think they can be encouraged to do those measures?
I could say yes and no, couldn't I? But that's not really what you want. Right. So is it solely the government's responsibility? It's not solely the government's responsibility, and it's not solely industry's responsibility. Industry has social responsibility, but it also has responsibility to shareholders. So there's a commercial responsibility. Industry is doing and is using a whole range of measures to reduce its costs, which in a lot of ways also reduces its impact on the environment. And that's been going on for a long while. The government has been incentivizing industry to improve its environmental sustainability, and it's been doing that through a number of different schemes. I'm just thinking the most recent one I can think of is something called the Industrial Energy Transformation Fund, where basically the government sets up a competition where industry can bid for funding, and it's part funding, to help them decarbonize. Now, the reason why that actually works is because generally industry, when it looks at an investment, will look at return on investment. And if the return on the investment isn't as good as putting the money in the bank, obviously it doesn't do anything. So if you say, I want to put a more efficient part of my process, a new motor or something, which is more efficient, but its payback is 5 or 6 years, industry will not do that project, so they won't finance it. The idea of Industrial Energy Transformation Fund is that the government will pay for some of that, and that suddenly makes a project to industry look like it's at least cash neutral, so it goes ahead. That policy of incentivization is great, but at the moment with the government, it's only on very small scale. So if that was scaled up, industry would do more things to make itself more efficient, and the bits of industry which weren't efficient wouldn't be competitive. So it's a sort of accelerator. So yes, I think the government needs to work harder at incentivizing industry, and I think industry needs to then see the real benefit, commercial benefit of using some of those incentivizations. I think also society needs to get a bit real with this stuff, and also think, decarbonization, it's going to cost everybody. It's going to cost everybody if we don't do anything. It's going to cost everybody if we do something. So we need to start thinking about being responsible. It's everybody's problem.
Yeah, and it's going to cost us either way. You're absolutely right. Joan, would you like to come in on this one? So we're talking about kind of whose responsibility is it to incentivize emissions reduction? And I guess what role can industry play as well as government in that incentivization?
I would agree with the previous speaker. It has to be both. Because, you know, for companies, particularly companies who say they live by their values, like Steve says, for years and years and years, we have worked hard at continuous improvement, reducing energy, reducing emissions, because it all makes good business. If you use less energy, it's more cost effective, it's less waste. If you are more efficient, you have less waste, it's more cost effective. So it's all good. But there's a limit to what you can do when you sell in a global market. You know, so, you know, one of the reasons I was able to retire early and come and give back as an academic was because the site I was at shut down. And why did it shut down? Well, it was a really old plant that we kept open and safe long enough until the process moved to China, because it was a lot cheaper to make it in China. So if we over legislate, we'll move all the jobs somewhere else. But if we don't legislate, then, and we don't do the legislation cleverly enough, we don't get better. We don't meet our environmental existential challenges we have. So we have to do both, but it can't just be legislation in the UK. It has to be global, and global partnerships are really important. And that's one of the reasons I spend quite a lot of my time working on policy work, because I think that's really crucial to finding a way forward that everybody can win rather than everybody losing.
Absolutely. Steve, did you want to come back on that?
Yeah, I mean, I'm agreeing with that, actually. I mean, it's the big point from that. It's a global problem. You can't just move things to different countries. You know, it's that we've got a global problem. We need to have a global solution. Unfortunately, then, because people are human beings, we need a balance of carrot and stick sort of approach to make sure that everything works and everything's equitable. So, yeah, I totally agree, Joan.
Yeah, absolutely. I mean, the carbon dioxide and other carbon emissions, greenhouse gas emissions, don't care which country they originated from. They still go up in the atmosphere and cause us problems. And I think that's sometimes one of the challenges with the way we quantify things. Is it's easy to make one person or one industry's footprint decrease, but it's because we've offshored it and sent it somewhere else. And actually, that may have made the global picture much worse. And there is some real challenges around there. I'm just going to come to Reinhard's question because it's kind of connected, and then we'll move on. So the question was, are the two underlying problems or barriers of a green and just transition private profit making and insufficient national planning to create the necessary infrastructure? So I guess it's a post question of, do we think those are the two main barriers? And I'm going to add on to it, if they're not the two main barriers, what are the barriers instead? Sol, do you want to take that one first, and then I'll come to the others on the panel?
Let me take the second bit then. The insufficient national planning. So it's not that we've done insufficient planning, it's that we haven't actually acted on any of our plans. And that's basically been the story for like as long as I've been in energy. We've in fact replanned the same thing continuously, but never actually done it, which is why I sound slightly frustrated, because that's what we do.
So how do we change that? How do we make the plans be put into action? What I think individuals need to do?
So I guess it comes back to the previous question a bit with Joan and Steve, that actually the decision to invest money for decarbonisation was made when we passed a law saying that we were going to be net zero. Like, that was when the decision was made, and quibbling about how much it will cost now is just a reflection that law wasn't understood. But the money's essentially been committed. I think there are a few questions about CCS, and ultimately that money needs to come forward for the infrastructure to be put in place. We know what that infrastructure needs to look like. We've planned it 4 or 5 times. and ultimately that will have to be the government who builds the infrastructure, because no private actor will take the risk on the infrastructure and the containment risk that it poses, right? So no private actor will take that risk. It will have to be government that does it. On the private profit making, no, I don't agree that that's one of the things underlying problems. Actually, if you see, like, the greatest expansion of wind energy in the world was in the UK, when we had more relaxed planning regulations, and you had the fastest deployment of onshore wind, which is more efficient than offshore wind, than has ever been the case. And that was because private profit making drove installation of generation. And that ceased as soon as government stopped and changed the planning regulations. So I don't agree that that is an underlying problem. I think it can be a problem in some cases, but I don't think it's
not across the board. Yeah. It can also be a push to help things if done in the right way, I guess, is what you're saying.
Yeah.
Joan.
Businesses need enough certainty to make decisions, and usually businesses are looking for paybacks in small amounts of years. But if they're going to invest in something like hydrogen or huge electrification, it needs to pay off over a number of years. So Rachel and I are both involved in a hydrogen grant, and we were at a meeting with a bunch of lawmakers, and then another meeting in Paris with a bunch of lawmakers and researchers there. And in Germany and France, the government has published what the infrastructure, what the backbone for hydrogen and electricity is going to be over there. So businesses know with certainty that there's going to be a backbone, that there's going to be policies for 5, 10, 15 years. So that gives them security and to invest. So there's no lack of people wanting to invest. Rachel and I have talked to lots of people who are saying, we're just waiting on policies being there to make sure it's not going to turn what looks like would be a good investment to a stupid investment. And as Saul showed, if you don't have a backbone and you don't have certainty of a backbone, particularly for hydrogen, then you're not going to invest. And as we talk to people, so Rachel and I have been around talking to people, we hear the same thing over and over from people who are ready to invest. We have ITM Power here in Sheffield, and different governments have offered them lots of money to go and take their factory there. And it would be much easier for them to go and do it in Europe, where at least the policies have been set out and you have a good long-term strategic plan. The problem in this country is our politics, and therefore our policies are very, shall we say, election dependent. And you've seen that this year as well, and the short-termism. And my fear, and this is what I tell policymakers when I talk to them, and we have a report coming out on materials for net zero very soon, that basically said is we're going to be left behind if we don't take the decisions that Saul was talking about. And I echo his frustrations, but we can't give up. And just, the people who are asking about CCUS, my design project as an undergraduate chemical engineer was in CCUS, and that was nearly 40 years ago. And it was economically viable then if the policies were right. So, we need to get our politicians and our ministers listening to science and not just trying to get the next vote.
All right, I think we're going to come back to the CCS bit in a bit, but I've got a question from Linara, and I'm going to come to you first, Fanran, on this one. And it's, what frameworks can industries use to determine the most effective way for them to decarbonize their operations? I think it's a great question, because I think there is a lot of kind of openness and uncertainty. So how does industry decide what's best to do?
Yeah, this is a great question. I think the direct answer is there's no one solution fit all. So, but overall, we need to apply the life cycle thinking, hosting approaches to look at, not only kind of process itself or the technology itself, put into the system, because system to understand wide impacts and guided by these or some kind of the wider impacts, understand its wide impacts and put the material design in not only, for example, when we design a new battery, you probably use one particular material and then give you higher performance, but it might be not really environmental sustainable or higher environmental impacts. Also, quite probably supply chain not secure along these supply chain. For the whole industry, also vary because there's technology challenges. Some sectors, hard-based sectors, also lack viable green alternatives or technologies, or they're not mature enough for large-scale adoption. And when you quantify these kind of effective measures, really hard because their technology mature really vary on the different technology readiness level and hard to compare that. And so that be also quite difficult for industry to understand and also understand our investment opportunities. And then the second one on the effective, well, of course, we need some consistent policies and regulations to help us, to reduce the uncertainty and for example, using some uh, clear, consistent long-term policy and accounting frameworks, so it can help them to do the accurate and decarbonization or calculation, understand the emission targets, and also some mandating reporting of carbon footprints guided by these standards. And that's why the LCA regulation policy workshop led by Richard Rosman in next week at the Manchester. So that will be good opportunity if you are interested to understand more how we can create a consistent way of doing accounting to understand product sustainability and overall about life cycle analysis. Then I think that's a chance to participate. We will circulate this registration ways if I'm interested. So I hope that's it's quite a difficult question. I don't think it's really effective way or called a perfect way of doing that. So I stop here. Thanks.
It is a tricky question, I agree. Sol first and then Steve, and then we'll move on to the next topic.
I guess I'd challenge Fanran a little bit. So given that I'm a systems engineer, I'm not contradict him entirely, but I think there is an overuse of models, particularly, and as a modeler, this cuts me to the core. But there is an overuse of models which are simplistic in the levels of uncertainty in the development of technologies and the surrounding policy. So you can't attack government for bad policies when a war breaks out in Eastern Europe. And actually what we need to do is realize that our movement into a transition into a new economy has to be robust to things that change like that. If we invest into technologies which are built on brittle business cases, then we're making ourselves less resilient. And I think so. Models can be a way tool to assess those things, but I think we have to be careful about how we make them, and frankly make use of people like Steve and Joan who have lots of experience in the kind of calling BS when a model says something which is a bit silly. And the counterpoint to policymakers is that they've become very reliant on models, right? So they use models to make lots of decisions, but they're very naive about how those models should be used. And that's always the worst case scenario. So a really complicated model which is brittle, used in a bad way, can lead to very bad things. And that's just something that we need to learn and become more mature in the way that we use the tools that we've developed.
Go on, Steve.
Right. So just a bit of an industry side to things. And just listening to some of the things that are happening at the moment. a lot of this is about how agile things are. Yeah, we haven't done anything on a number of different things, and that's largely because from an industry point of view, it's not clear what to do. It's not clear on the policy, and it's not clear if you're an early adopter and you spend a huge amount of capex being an early adopter, are you just going to get left behind because you learn all the lessons and all your competition pick them up and jump ahead? So it makes it very, very hard for somebody to commit to the next 20 years of their business operation by being the early adopter, by jumping ahead. You know, models are one of the things that people look at, but generally, unless you can see somebody else has done it, you're going to be very nervous. It's like carbon capture in the steel industry. You know, at scale, I think Emirates Steel are the only people that are really, you know, using it. And it's very, very difficult to, as a business proposition, to say, we want to be next. We're going to make the big difference. You know, unless you're really sure about it. It's a time to market thing, maybe. You know, if you were selling food products, you might get in with the next Mars bar before anybody else did. But if you're making really, really big commitments, being an early adopter is very risky without support.
Yeah, that uncertainty is hard, isn't it? And it's almost the losses that might happen if it goes wrong. And I mean, your Mars bar example is a good one, but that would be a small part of a company's portfolio. Whereas what we're talking about with something like the steel industry is their entire, it's the entire business.
Yeah, it's massively capitally intensive. So the decision you make has to stick. I mean, this is why generally in the industry you see smaller steps and why you don't see these massive changes in technology unless somebody is very sure.
Yeah. Joan, did you want to come in on that?
I think resilience is a huge issue. Like you talked, Steve, you might be making an investment that costs $500 million, and therefore you need to be really sure. And so resilient to changes in policy, you know, resilient to a war breaking out in Ukraine, or, but that's where government has to come in. And unfortunately, our government hasn't come in a way to give that surety, as it were. But from everything we're seeing, I spend a lot of my time thinking about global risk and advising the government on risk for UK PLC. And, you know, one of the things that we have a big risk of is if we don't do this right, the loss of opportunity is vast. You know, one of the questions are, where do we have the opportunities to capitalize or benefit from this transition? And the reality is we're throwing away a lot of those opportunities because of the lack of the security, because people, you know, in order to take that big step, they need to do it. But we do have some examples. And I think the other thing is the bigger companies, people look to the bigger companies, but it tends to be harder for the bigger companies. And really putting legislation and support in for smaller companies to make changes is also important, because you see the percentage of people who work in small companies in the UK is pretty high. So we can't forget about them as well. And, you know, we often forget to look outside of the UK because, you know, it's always better if it's us. But another questioner said, well, what about Scandinavia? They've already electrified steel. So, you know, we can learn from other government policies, but we can also learn from others. And I think we need to be more open and more agile, but we also need to think about how we become more robust in our industries in the UK as well for these changes, because I don't think it's going to get any quieter in changes. All the predictions are there's going to be more socioeconomic unrest, more climate change, more change, and so we have to get used to handling it.
Fanran, did you want to come back on that really quickly and then we'll move on?
Yeah, just to add on about these data uncertainty. I think the most important thing is what I've shown in my slides is about the transparency and about the data, where you get the data, and how to best inform your model development. I mean, as so mentioned, well, model run, some are useful, and especially predicting the future is really hard. How can we best inform these technology development using data, using some first-hand data? How can encourage the data collection for industry to share with different stakeholders? Because doing academia and what we have developed might really hard and maybe really easily be misunderstood and misinterpreted by the industry partners, and how we can kind of create this consistent framework and also ensure this consistent interpretation of these outputs, of these research outputs or whatever, for to guide the technology development. I think that's quite key. Yeah.
Brilliant. Agreed. Right, we've got a few questions about steel that have come in. So Steve, I'm going to come to you first. Some of them are on the Miro board. So there's a few. I'm going to give you an overview of all of them and we'll see what we can do. So the first quick one is, does the UK have industry leading steel production, or are we B tier? And then following on from that, when transitioning steel production to less CO intensive methods like electric arc furnaces or hydrogen, can the existing waste heat recovery systems be used in the same way, or do we need modifications? So that, I guess that's a question about, if we change one bit of it, do we have to change everything, or can we use the existing waste heat recovery? And maybe you can comment on the whole, can we use the process Scandinavia are using as well?
Yeah, so to start off with, are we beat in the UK? Is that the end of it? My view, personal view, we're at the best possible position we can be at the moment, because the carbon intensive part, heavy end, we call it, the bit which makes iron, the bit that makes steel, that part has got to the end of its asset life. Whatever happens, forget about policy, forget about anything else. It's a piece of equipment that's got to the end of its life. So it has to be replaced with something. It just so happens that it's coincided with a lot of other need, sustainability and environmental needs, and with a lot of policies. So I think in terms of, is the UK steel industry beat? I think not. I think it's just at a point where it could become something that's quite special. However, with the
I was looking so positive.
Yeah, well, with the background to that, some of the things that enable that are energy costs, green energy production, all the things that we've talked about before. There's lots of things behind it. In terms of, can you reuse a lot of the equipment you've got for heat recovery? A lot of the systems, half of the plants on these sites is going to disappear with all the equipment that's associated with it. So the main reuse, I think, unfortunately, goes with the technology, which is the easiest to move to technology and the most agile at the moment. So we talked about being agile in the steel industry. There are lots of things that could be done. Could use carbon capture, could start to make iron, an experiment with using hydrogen as a reducing agency. None of these things are fast, and none of them are going to get over the problem that the equipment that's underlying all of that is at the end of its life. So you're sort of left, with the thing that's in the news at the moment, that the steel industry in the UK is moving to electric arc furnaces, and the idea is that we won't, as a country, make iron anymore in the short term, medium term, that what we'll actually use is the scrap that's available for export in the UK, and we'll melt it down. And what that really means is that's an 80% reduction in CO2. It's a massive step. It doesn't fix the problem because there's still CO2 from that industry, but it makes a big impact. And if we could do it quickly, it's agile. And that's what we've just been talking about, is doing it quickly. So to answer the first part of the question, is the UK steel industry beat? No. It could be in 3-4 years' time, it could be ahead of Europe in making low carbon steel. And that's where we need to focus. And that's where government support, and it needs to be agile. Making that transition will cause job losses, and it's government policy that should be picking up the fallout from this move to make sure that those it doesn't have to have job losses. There's lots of things we can do with policy to incentivize other parts of industry to pick up the skills before we lost in those areas. That's government. That's not industry, that's government. So, there's a lot of stuff like that. Can we reuse the existing technology that's around these heavy ends of the plant? I think actually, probably not. But in true recycling, what we can use is the equipment that's already on these plants. We can reuse that for other energy saving in the new equipment.
New system.
Yeah, so we don't have to scrap some of that equipment that's already on site. We just need to repurpose it. What
a great answer. And that leads us actually into this next trail of questions. And Sol, I'm going to come to you first. Colin commented in on the chat that he understands that Emirates Steel CCS is used for enhanced oil recovery. So we've got a few queries around that, but it brings us on to the whole chunk of CCS questions we've got. And I'm going to try and paraphrase and summarize them so that you can all contribute. So the main gist of the questions is, how can we trust CCS technologies if we haven't really seen them deployed on big scale? So is there anywhere where CCS has been demonstrated at sufficient scale? Are we confident that it will work and be affordable? And particularly within the UK, there's a comment that it's never worked globally at the 90 to 95% CO2 capture rate. So, and that would be required for the UK. So how can we have confidence that it might be something that will actually be useful for us in the UK in future? Sol first.
I feel like I've been answering this question for my entire career. So we know that each bit of it works because it has worked. So I understand the point about 90 to 95% capture rates is probably, I'll come on to that later, but large scale carbon capture has been deployed on a power plant. Every other element of the CCS chain has been deployed for at least 30 to 40, 50, 60 years. So the transportation elements have been active in the US for a long time for enhanced oil recovery. Capture of CO2 at small levels has been, it was on the space shuttle. So we know how to capture CO2 and strip it out of flue gases. It's not the capture rates which are difficult. It's the finances, because CCS depends on basically creating a new waste stream. So it's effectively like trying to recreate wastewater as a thing. It has no value in and of itself, other than it's getting rid of an effluent that we don't want. And that creation means that creating that market means that government needs to come forward and provide a basis in which CO2 release is either penalized or sequestration of it is rewarded. And I think there's a further question about ETS and carbon capture credits, carbon removal credits. So they are an attempt to incentivize exactly that. Whether they currently work or are well designed is a completely separate issue. Ultimately, technology-wise, this works. It has worked. It has been demonstrated at power plant level. And actually, what CCS needs as a technology is to do it more so that we get better at it. But again, that's been the case for like the last 20 years. On the 90 to 95% capture rates, yes. For the power plant where capture was applied, it was not at that level, but that was because it was trialing a technology. And there were issues with that technology. And so this was in Saskatchewan, but that's what you expect the first time you deploy a large-scale technology. It's no different from any other thing. And I think like the further question, well, the further point about kind of the CCS being for enhanced oil recovery, I think that kind of evidences the circularity of the argument. So we do know how to do it because we've done it for things like enhanced oil recovery. We might prefer not to do enhanced oil recovery, but the fact is that we can capture CO2 and put it in the ground, and we can demonstrate that at large scale. So we can do it.
And I guess the reason it's done for advanced oil recovery is because there's a profit in doing that, in that you're getting the oil. And it's like you were saying at the start, Sol, that the finance isn't there for just burying the CO2, because who's going to pay for that, or where's the incentive to do it? Just on the you mentioned the carbon removal certification framework, and the bottom of Linara's question was about do we believe that removals certified under CRCF would be eligible for trading under the EU ETS scheme? Sol, do you have a response to that?
I guess I'm not sure the legal framework's in place for that. We've done some work assessing the certificates given under that framework, and I'm not sure that they perfectly assess the level of carbon removal or the duration of that carbon removal. So comparing different negative emission technologies is a difficult thing, and I'm not sure that policy does it perfectly, but at least it's a move in the right direction, and it's starting to put incentives in for some of the technologies that we need. I guess what is worth emphasizing is that the UK's plan for net zero is entirely dependent on CCS in some form, right? We don't get to net zero without having CCS applied in some way. So we can make it work. We must make it work if we're going to meet our obligations, but that comes at cost and probably standing behind risk, which we're used to in other cases. We just need to get used to it in carbon capture.
Steve and Joan, do either of you want to come in on the carbon capture discussion?
I think from an industry point of view, I think I totally agree. I mean, it's an essential thing. There's not going to be one technology that gets us to net zero. It's going to be a range of technologies, and it's going to be joining up our whole sort of energy, power, heavy industry ecosystem, and it's going to be making that work properly. I mean, as we fix one bit, we're just moving the problem around. Great, we can have electric arc furnaces. They need a hell of a lot more electrical energy. That's got to come from somewhere. So that's coming from the power plants. What are we going to do with the power plants here with energy generation? It's not all renewable at the moment. And if it was, we've got to get some steel somewhere to build some windmills. It's a really big question. And I think what happens is people probably oversimplify it and just split it up into little bits and look at them by themselves. And it's got to be a problem that's tackled as a whole thing, not just as small parts. That's my view.
Joan, I've got a quick fire question for you, and because we're starting to run out of time, it's got to be a quick one. So how does industrial decarbonisation culture vary from working in the US and then in Europe?
Well, what you have to realise is the US is a very big place. Now, Europe has lots of different countries, and so there is differences across Europe. There is obviously the Inflation Reduction Act in the US, so there's some incentives for companies, but generally the political environment, there's still probably a huge percentage of people in the US who don't believe that climate change is a real thing, shocking as it may seem. And the way businesses make decisions over there, the way there are big companies, big global companies work to the same standards all over the world. But there are a lot of companies that I would say, this is my experience, is that whether it's environmental law, safety law, it's only a problem if I get caught. So there's that sort of bit, is they're only going to do it when they're made to have to do it, or there's really, really good government incentives. So it's much more polarized than here. And also there tends to be much, much bigger incentives for people over there. So the US has the possibility to make huge strides because it's a huge country. If one chemical plant or one big oil refinery does CCUS and it goes well and it's advertised, then loads of people will follow, and one of them's happening right now. So they have the agility, because of the sheer number and size of companies, that they can change things quickly, and they tend to also make big decisions quickly, maybe more so than our government. So they could leap ahead really quickly just because they've got, you know, such varied and such number of companies. So it's a very different political environment, though, completely different. You know, when you have engineers, degreed engineers who've got degrees from Stanford, you know, hugely well-educated people that work for you, and they will argue to your face that climate change doesn't exist. It definitely has a different perspective.
That makes it trickier for sure.
Yeah.
Right, Sol, this is a quick question for you. Would you agree that using biomass is not truly a carbon neutral solution? See if you can answer it quickly, because then I've got a final 2 quickfire questions before we wrap up.
No, I don't agree with that. I think it can be, and I think it might not be. I think both of those things can be true depending on the supply chain of the biomass, and how it's used. So I agree that in some cases it's not, but I disagree that it's not in principle the case that it is not carbon.
Yeah. Okay. We don't have time to delve into that one, I'm afraid. We're going to take Jim's question as our first quickfire, and then I've got a final quickfire and we'll finish. So what are the new industry or new technologies that we in the UK could focus on moving towards a kind of lower carbon future? So less than 10 words. Is there somewhere new we should focus on, or should we just be working on what we have and improving it? Steve first.
I think the main thing with that is agility. There's no one thing that we need to focus on. What we need is to actually do something. You know, like we've been talking all the way through. It's a whole range of things.
Yeah.
You know, some things are difficult, some things aren't. So we need to do something. Bit like sailing, you have to tack to get to where you're going.
Yeah. Sol, any new technologies we should focus on?
So I guess batteries are there. So we do have a research base which is world-class across all of the things that Jim mentions. And I think we need to get better at utilizing that to create industries. So I think we could be leading on all of those things, and we have to get better at making use of that expertise. But I think one thing that the UK is good at is having expertise in things. It's something that we export quite well, and being agile in drawing that into an actual industry is what we need to get better at.
Okay. Joan.
Oh, difficult one. I think, I mean, one thing we could be really good at is nuclear hydrogen, but that could take a long time. Certainly working with France, we could be really good at that, and fusion. And certainly working with France and Germany together, we could make a lot of inroads in hydrogen. There's recycling of batteries. If you think about what Steve said right at the beginning on the future for steel was recycling steel we've already got in this country. If we're going to run out of lithium and we're going to run out of copper, the best way to make UK resilient is to get really good at reusing and recycling.
Okay. And your final quickfire question, we're going to go in backwards order for this one. So Joan, then Sol, then Steve. If you could pick one thing that would really make a difference to help us decarbonize our green giants, what would it be? One thing that you're going to focus on first. Joan, in less than a sentence.
UK backbone energy policy secured for 15 years.
Good almost sentence. Sol.
Can I just copy Joan?
Ditto what she said.
That would do it. Yeah.
All right, Steve.
And you know what? you can't do any of this without having an energy system and having a policy that goes with it.
Okay.
Yeah, that's where it all. That's the thing that makes everything work.
So Joan has encompassed it for us, and that's the thing that makes everything work. Brilliant. A huge thank you to all of our panel, to Steve, to Sol, to Joan, and to Fanran, who we lost partway through, but some really great discussion, great answers. Thank you for sharing all your expertise, and a big thank you to all the audience for coming on, listening and asking such great questions. Ava, it's back to you.
Hi, yeah, not much really to add to this. Sorry, I've acquired a friend. Thank you so much to everyone who's joined us today. Just to echo what Rachel's just said, and thank you to Rachel for chairing this wonderful discussion. This was recorded, so you can rewatch it, send it on to friends, colleagues. So that will be published on the Grantham Centre YouTube. Please follow that QR code for other Festival of Debate events that are happening. And other than that, just thank you so much. We're 1 minute over, but I think we could have gone on forever. So we've done well. So thank you very much, and have a good afternoon, everyone, and goodbye.